We shall now discuss about derivative as a rate of change. Given a function f defined by y equal to f of x, the average rate of change of y with respect to x over the interval x sub 1, x sub 2, which is denoted by delta y over delta x, is defined by delta y over delta x equal to f of x2 minus f of x sub 1 over x2 minus x1, or y sub 2 minus y sub 1 all over x2 minus x1. So to illustrate, say this is the graph of y equal to f of x sub 1 to x sub 2. From this point, x sub 1, f of x sub 1, to the point x sub 2, f of x sub 2, we indicate this as point P with coordinates x1, y1, and point Q with coordinates x2 and y2. The change in y is delta y, and the change is delta x. So the average rate of change of y with respect to x over the interval x1, x2, which is equal to the change in y over the change in x, is simply the slope of the line connecting points P and Q. On the other hand, we define the instantaneous rate of change of y with respect to x at the point x equal to x sub 1 is given by instantaneous rate change of y with respect to x at x equal to x sub 1 is simply dy dx at x equal to x sub 1, or it is the derivative of the function f evaluated at x sub 1. As an example, let us say that we're given the function f defined by f of x equal to x squared minus 2x plus 3. So this is our y. Determine the average rate of change of y with respect to x on the following intervals. One, 2, 1, 1.5, 1, 1.1, and 1, 1.01. Determine also the instantaneous rate of change of y with respect to x at x equal to 1. Alright, so our y is equal to x squared minus 2x plus 3. For letter A, the interval is 1, 2. So that means that our x sub 1 is 1 and our x sub 2 is 2. So we get f of 1, which is equal to 1 squared minus 2 times 1 plus 3. That will be 2. And our f of 2 is 2 squared minus 2 times 2 plus 3, which is equal to 3. So f of 1 is our f of x sub 1, and f of 2 is our f of x sub 2. So delta y over delta x is y2 minus y1 all over x2 minus x1, or f of x2 minus f of x1 all over x2 minus x1. Our f of x2 is 3 minus f of x1, which is 2, divided by the length of the interval, 2 minus 1. That will give us 1. So, over the interval 1, 2, y changes at the rate of 1 unit with respect to x. With every 1 unit change in x, your y will change on the average 1 unit over the interval 1, 2. So proceeding now to the second interval, 1, 1.5. Our x sub 1 is still 1, but our new x2 will be 1.5. So f of 1 is still 2, but your f of x2 is f of 1.5, which is equal to 1.5 squared minus 2 times 1.5 plus 3. So 225 minus 3 plus 3 gives us 2.25. Delta y over delta x is f of x2, 225, minus f of x1, which is 2, all over 1.5 minus 1. So that gives you 0.25 over 0.5. That will give us, how much? Let me see, 2.5, okay? So 0.5. So for every change in x of 1 unit, your y will change by an amount of 0.5 units on the average over that interval 1 to 1.5. So we do the same thing for the interval 1, 1.1. So we just calculate for f of 1.1, that is 1.1 squared minus 2 times 1.1 plus 3, 121 minus 2.2 plus 3. That should give us 4.21 minus 2.2, and that is 2.01. Alright? So delta y over delta x is 2.01 minus 2 all over 1.1 minus 1. 0.01 over 0.1 will give us 0.1. We shall now proceed to the last interval, which is 1 to 1.01. Our x sub 1 is still the same, equal to 1, and x sub 2 is 1.01. So calculate for f of 1.01. That should give us 1.01 squared minus 2 times 1.01 plus 3. That is 2.0001. Right? So delta y over delta x is 2.0001 over 101 minus 1. So minus 2, no? 2.0001 minus 2 is 0.0001 over 0.01. That gives us 0.01. So it started with the interval 1, 2, followed by 1, 5, or 1, sorry, it should be 1 to 1.5, then 1 to 1.1, and finally 1, 101. Our delta y, delta x over these intervals were 1, 0.5, 0.1, 0.01. So intuitively, as delta x gets smaller and smaller, our delta y over delta x gets smaller and smaller, and the limiting value is 0. So from this alone, we can say that the instantaneous rate of change of y with respect to x at x equal to 1 is 0. And we can validate this by getting the derivative of y. So let us write y equal to x squared minus 2x plus 3. This is actually our f of x, right? So f prime of x is equal to 2x minus 2. The instantaneous rate of change of y with respect to x at x equal to 1 is f prime of 1 equal to 2 times 1 minus 2 equal to 0. And this agrees with our intuitive knowledge about the limiting value of delta y over delta x as delta x approaches 0.